Hello guys, this is Prime Concept. In this video, I want to look at wave characteristics. In our previous video, we explained we introduced waves, explained the classifications of waves, we explained the types of wave. We said we have the mechanical waves, which are waves that requires material medium, and non-mechanical waves, which are also known as electromagnetic waves. That is waves that do not require material mediums for their propagations, right? We also explained the two types of wave motion. So we said we can have the transverse wave motion and we can also have the longitudinal wave motion. But one of the things we didn't do in that video was to describe the wave form or wave diagrams for these kinds of wave motion. Now the transverse wave motion is usually of the sinusoidal waveform, right? So for a transverse wave motion that is periodic, it usually follows a sinusoidal waveform. So this is the waveform for a transverse wave motion. So a transverse wave motion, this is the waveform, like this, sinusoidal, right? Yes, and when we say sinusoidal waveform, it can either be the sine waveform or the cosine waveform. So both waveforms are sinusoidal. So this is the waveform for transverse wave motion. Transverse wave motion. So this is the waveform. Then for our longitudinal waveform, this is the waveform. Now, the transverse wave motion is made of a crest and a trough, right? While for the longitudinal wave motion, we have is made of regions of compression and rarefaction. A region of compression is simply a region where you have high pressure. That's to say the waveforms are so much close to each other. That's where you have a region of compression. So a region of compression is a region of high pressure, while a region of rarefaction is a region of low pressure. So in the rarefaction region, you have a kind of expansion. So this is how it is, like this. Though I'm not drawing to scale. So you have something like this. So this is your longitudinal waveform, right? And you notice that in this region, the waveforms are clustered. So this region is your region of compression, right? Now, while in this region, you will notice that the waveforms are spaced around. So this region is your region of rarefaction. So this is your region of compression again. This is your region of rarefaction, and so on. So this is the waveform for the transverse wave motion, while this is the waveform for our longitudinal wave motion. So this concept should be clear to you. Now, in this particular video, we want to analyze the characteristics of waves, wave characteristics. So we're going to be drawing these characteristics from our transverse waveform, which is a more common waveform for us. So, since this is my transverse waveform, I'm going to label this diagram so that we can now point out some of the terms or characteristics that are found in this waveform. So I'm going to, of course, this horizontal is our time axis, and this is our y, vertical displacement. So this particular point, which is the highest point you have here, is known as crest. So this crest, this trough, and this height is A. Same way, this height is also A. Distance from this point to this point is lambda. So this is it. So we're going to mention some of the characteristics of wave from here. And number one characteristics we want to mention is what we know as crest. I want to mention crest. What is the crest of a wave? The crest of a wave is the highest point of displacement of that wave. A crest is a point, it's not a distance. So it's the highest point of displacement on that wave. So if you notice on this my waveform, this particular point is the peak point, the highest point, the maximum point, not maximum distance. So the maximum point is what we know as crest, maximum points, right? Then the next I want to mention is trough. Trough is the lowest point on the waveform. So you can see this point. This is my trough, the lowest point on the waveform, which is this particular point, the center, right? So I can call it minimum point. Minimum point. Number 3 I want to mention is wavelength. Wavelength is denoted with the symbol lambda, right? Yes, what is wavelength? Wavelength is the distance between any two successive crests. So this crest and this crest are successive. So when you say successive, simply means the crests that follow immediately after each other. So if I'm to redraw something like this, and so on. So this is 1, 2, 3. Now you will notice that crest 1 and crest 2 are successive. Crest 2 and crest 3 are successive. So it means if I'm to measure a wavelength, the wavelength will be the distance from this crest to this crest. This is a wavelength. Or the distance from this crest to this crest is also a what? A wavelength, right? Yes. So that is what we mean. Or the distance between any two successive troughs. So this is a trough. The distance between these two troughs is also a wavelength. Or the distance between these two troughs is also a wavelength. So wavelength is the distance between successive crests or successive what? Troughs. That is a wavelength. I believe it's clear. Number 4 term we want to talk about is period. Period is the time taken for one complete circle. So when we say circle, this is what we mean. Period, the time taken for one complete circle, like this, CYCLE. So the time taken for one complete circle is what we know as period. Now, what is a complete circle? A complete circle is the point of displacement from 0 to where the wave hits 0 after going through a minimum, right? So from this point to this point is a circle. From this point to this point is what? Half circle. So from this to this is a circle. So the time taken for this wave to make this complete circle is what we refer to as what? Period. So if I come and label this axis now, I label here 2 seconds, and I label here 3 seconds, and I ask you, what is the period of this oscillation? What would you tell me? Of course, you are correct. The period is what? 3 seconds, because the period is the time it takes for this to make one complete circle, which is 3 seconds in this case. I believe this is clear. Now, number 5 then we want to mention is frequency. What is frequency? Frequency is the number of circles in 1 second. Frequency is the number of what? Circles in 1 second. That is frequency. How many circles you have in 1 second. So if I should label this now, let's say this diagram, I come to this point and I call here, let's say 1 second. So this is 1 second. And I should ask you, what is the frequency of this waveform? It's very simple. Frequency is the number of cycles you have in one waveform. So from here, from this point to this point is how many cycles? Is 1 cycle. From this point to this point is how many cycles? Is 1. So it means we have 2 cycles in 1 second. So the frequency of this diagram is what? 2 cycles in 1 second. So what is the unit of frequency? The unit of frequency is cycles. Cycles per second, or you can say hertz. So frequency is measured in cycles per second, or you say hertz, right? Yes, so I believe this is clear. Now, we want to mention another term. Number 6 is what we know as phase angle. Phase, you can just call it phase, or you call it phase angle. So, and phase angle is denoted by the symbol. This is it. Phase angle is denoted by the symbol phi, right? So phase angle is the angular displacement of a waveform that starts at the origin at the time of 0, and another waveform that does not begin at the origin. Phase angle is the angular displacement between 2 waves, for which one of them starts at the origin and the other one does not start at the origin. Now let me explain. But first, you should note that phase angle, it simply means angular measurement of displacement. And phase angle is measured in radian because it is an angle. Now say I have this waveform like this. I have this wave. So I'm going to call this wave A. And then wave A, you can see starting from the origin, right? Yes. Now say I have another waveform like this. And so on. So I have another waveform. This is wave B. Now you would notice that there's a distance. There's a distance that separates A and B. And this is the length of that distance. So this length of this distance, when you measure this distance of separation between A and B at this point, when you measure it in radian, then it means what you have measured is what we know as what? The phase angle. So phase angle is the angular displacement between 2 waves, where one starts at the origin and the other one is displaced away from the origin, right? Then that is called phase angle. So you can say phase difference if the 2 of them do not start from the origin, then you can say phase difference. So this is phase angle. Now if you should be asked under exam conditions, say between wave A and wave B, which one of these waves is leading and which one of them is lagging? When you say leading, it means the one that is ahead, the one that is faster. So when you say lagging, it means the one that is behind. So between wave A and wave B, which one is leading? A lot of students may get it wrong and choose wave B, but that is not correct. The wave that is leading in this case is wave what? Wave A. So you simply say that waveform A is leading wave B by a phase angle of whatever it is. Let's say this is pi over 6. Then we can say that wave A is leading or is ahead of wave B by a phase angle of pi over what? 6. So I believe it's clear. Now, how do you know which wave is actually leading? The wave that reaches or attains its maximum first is the wave that is leading. So if you check, this is our time axis. That's our time axis. If I'm to label this, I can decide to label this place, let's say 2 seconds. This place, call it 4. This place 6. The next one, I'll call it 8, and so on. Now if you check, this is the maximum point of wave A. and this maximum point was attained under how many seconds? 2 seconds. This is the maximum point of wave B, and this maximum point was attained under how many seconds? 4 seconds. So it means that wave A that attains its maximum at a shorter time is ahead of wave B that attained its own maximum at a longer time. So it means that wave A is leading wave B by a phase angle of pi/6 radian. Or you can say wave B is lagging behind wave A by a phase angle of pi/6 radian. So I believe this concept of phase angle is clear to you. Now, number 7th term we want to mention is what we know as wave number. Wave number. Wave number is denoted by the symbol K, right? Wave number is the number of wavelengths you have in one circle in 360 degrees. So the number of wavelengths that is present in one circle, you know as what? Wave number. So, and wave number has a formula. K is equal to what? K is equal to 2 pi over lambda, which means the number of wavelengths you have in one circle. One circle is 2 pi or 360 degrees. So the number of wavelengths in one circle is what you know as wave number, right? Yes, and of course, you should also take note of the fact that phase angle has a formula. Phase angle phi is given by K times X, where K is the wave number, then X is the what? Linear displacement along the X axis. So I believe these terms are clear to us, right? Now let's look at something else very important which we know. I want to look at equations that are involved in wave, right? Equations that are involved. Now, one equation that you need to know, which is very common, one equation that you will be dealing with often is V equals F lambda. So V equals F lambda is a common equation where V in this case is what? Is velocity. V is velocity. F is frequency. Then this is what? Wavelength. Right? Yes. So this is one equation that you should be familiar with. Number 2 is to know that F, which is frequency, is 1 divided by period. Right? So this is a relationship for frequency. Of course, you should also know that frequency F is omega over 2 pi. So this is also another formula for frequency. Omega over what? 2 pi. Where you can simply say, if you should cross multiply, you can say that omega is what? 2 pi F. So I believe this formula is very you're very conversant with it. So omega is 2 pi F, right? What is omega? This is known as angular frequency or speed. Is either you call it angular frequency or you call it angular speed, and it is measured in radian per second. So the unit is rad, which is radian per second. That is the unit of angular frequency. Also, you should know that period T is 2 pi over omega. T is what? 2 pi over omega. So these are formulas you should be conversant with, to be dealing with them. V is F lambda, F is 1 over T, F is omega over 2 pi, T is 2 pi over omega. So these are formulas you should know. And then finally, one of the most important equations is what we know as equation of a plane progressive wave. So we know that as wave equation. Wave equation is an equation that describes the displacement of the vibration of the particles with respect to the displacement or the direction of travel of the wave itself, right? So we know that as wave equation for a plane progressive wave. So it is given as y equals a sine omega t plus or minus phi. So this equation of a wave, y equals a sine into that, right? Now remember I told you that this wave we're talking about, for a transverse wave, it can either be sinusoidal, which simply means it can be a sine wave or a cosine wave. So if I decide to use y equals a cos, it will still be correct, right? It means that wave did not start from the origin, right? So that is what it means. So we have y equals a sine this plus or minus this. Now if you recall, you would know that our phi phase angle, we mentioned earlier that phi is what? Kx. So I can write that as kx. So where y is the displacement of the particles of the wave. So it tells you the direction in which the particles of that materia are vibrating. Then x is the direction in which the wave is propagating. So these are two different displacements. This is the displacement of the particles of the medium, while this is the displacement or the propagation of the wave itself. Now you take note, we have a plus or minus, which simply means that the wave can travel either in the positive or negative direction. So when I'm using plus, whenever you see plus in this formula, it simply means that the wave is propagating in the negative x direction. Now when you see minus in this equation, it means the wave is traveling in the positive x direction. So what it means is that if I give something like this, y equals a sine omega t plus kx, and they ask for the direction in which this wave is propagating, simply means that the wave is propagating in the negative x direction. Since this is positive, it means that my wave is propagating in the negative x direction. I believe this is clear to us. I want to still do a little modification of this formula. We have y equals a sine omega t plus, what do we know k to be? We know k to be 2 pi over lambda then times x. So this is also the equation, right? Any one of them can serve us. Now let's still do some more modifications. We have y equals a sine, we know what omega is, right? Omega is 2 pi f. So omega is 2 pi f then times t plus 2 pi over lambda times x. So we can still have this. Meanwhile, you should note that a in this case is what we know as what? Amplitude. Amplitude simply means the highest vertical displacement, maximum vertical displacement. That is amplitude, the maximum vertical displacement, right? Yeah, so this can still be the equation of our wave. We can still do some more simplifications or modifications here. You can clearly see that 2 pi is common in this. So I can still write this as y equals a sine, bringing out 2 pi, I would have sine 2 pi into what now? Into ft plus x over lambda. So I can still have it in this way, right? And it will still be correct. Now I can still do a little more modification to this. Why I'm doing this is so that any one of these you see in your option, you won't be confused about where it came from. To be clear to you, all these things I've been doing came from this initial wave equation. So I also know, if you recall, f is actually v over lambda. So if I decide to replace f with v over lambda, I would have that y would be a sine 2 pi into what now? V over lambda times t plus what? X over lambda, right? Yes. Now you then notice that 1 over lambda is common. I can bring it out so that I'll have that y is a sine 2 pi over lambda, right? Into what now? Vt plus what? X. So this is also my equation of wave. So I believe this is clear. So take note of this. Is not some strange formula. It's very simple. We just progressed from the first one to arrive at this. So depending on what they have given you under exam condition, you should be able to arrive at this. So thanks. If you have followed me up till this point and you are yet to subscribe, please do well to hit the subscribe button, right? And then like this video, comment and share with 10 of your friends. Tell them this is prime concept. In my next video, I'll be solving a problem under these waves, right? I'll be using these characteristics to solve some problems. I believe the concept will be very clear to you. Thanks for watching.